maybe I'll talk real slow. My name is Ben Runchie. I'm a solutions engineer, architect with AxonIQ. I work out of the United States, and if anybody knows where Minneapolis, Minnesota is, it's not too far from Chicago. So I'm here to introduce Marc. He's one of our partners with EventDriven. He's done a great job of basically taking my thunder here with all these screens with his name and the name of the presentation on it. So he's going to answer that question that he had earlier. And afterwards, remember, let's use the app to put any Q&A, or if something comes up while we're asking those questions, I'll be more than happy to come around and either repeat your question or give you the opportunity to speak in the mic if you want to hold the microphone. It's always fun. So, all right. So with that being said, I think we're 11:59. I think we're good.
All right.
We can get started. Marc, thank you.
Thank you. So yes, my name is Marc. It's great to be here. I'm the CTO for a Swedish consultancy firm called EventDriven, where we specialize in cloud-native app development in general, with a particular emphasis on event-driven architecture, and of course, being partners with AxonIQ. A lot of that work revolves around event sourcing. And I wanted to use my time here to talk about how event sourcing can help build event-driven APIs. So what are event-driven APIs? Why do we need them? How do we implement them with event sourcing? I want to explore that in this talk. So let's start off with what is an event-driven API? Are people familiar with that in the audience? Have you built that before? Possibly. So in a sense, an event-driven API is something that exposes data, domain events that are generated within a bounded context, as event streams for other consumers, external consumers to consume for various workloads, operational or analytical or other forms. So when I say event-driven, I refer to the event-driven API being backed by domain events and those internal streams found within a bounded context. The resulting event stream, the things that we expose and publish, those properties are probably familiar to a lot of you. They're immutable, they're supposed to be durable, made persistent, and replayable. And you can compare an event-driven API and the various parts of it to a regular REST API. So you have an endpoint, much like you have a REST API endpoint, and a schema for what you can consume and actually also publish to an API. So if you're describing an event-driven API using a standard like AsyncAPI, you can actually not only subscribe to something, but you can also publish something to an event-driven API. However, in this talk, we're going to be focused solely on consuming something from an API. But the bidirectionality is important to be aware of. So the event data that we are exposing as event streams are straight transitions. So whenever things change from one state to another in a bounded context to a particular aggregate, these are the things that we want to push out, but not directly, but we need to be able to transform them in a bit. I'll talk about that a bit later in this talk. These event streams are often source aligned, so we're not particularly concerned with what type of consumer we have on the other end. We might be if there are special needs that consumers voice that we need to adapt to, but from a default point of view, we always publish something that is aligned to us as the owners of the bounded context. And so this question often pops up. Why do we need event-driven APIs? A data architect from a big Swedish retailer that does furniture. They're not maybe concerned with the term event-driven API, but they do want to expose data from one domain to another, or one context to another. So they are thinking about data products. So exposing data, but in a guaranteed form, so to speak. So you have certain SLAs, access policies, schemas, documentation, discovery mechanisms for using that data product. And those data products are then organized in something called a data mesh. I'm not going to talk about that in detail in this talk, but rest assured that event-driven APIs underpin that. They're the basis for data products and the overall data mesh. So let's illustrate this a bit. So we have a bounded context. I hope most of you are familiar with bounded contexts. Basically, it's in our overall domain model, we have, or domain, we have particular areas where we surround them with a boundary that we design, and within that boundary, a particular domain model applies. So you might have two bounded contexts, one's for sales, one for shipping. They each have their respective domain model, and an order in one is not probably the same thing as order in another. So that's basically the quick definition of a bounded context. So in one bounded context, whenever we have something changing to an entity or an aggregate from in some event source, we publish domain events. And these domain events are then translated through a separate layer for operational and analytical contexts to consume that might be already existing or will exist in the future. So this particular part, I've written OH, stands for open host. So those of you who do context mapping probably recognize that term. We expose these domain events in a particular format with a published language so people can really understand what is being offered from this context. You might think that, isn't there something missing, like an anti-corruption layer, because we're actually taking something and translating it, transforming it in something else that we publish? That's probably true, but I haven't explicitly detailed it in this slide. But we're doing something with these domain events before they actually get published to the ether. Now, this can also be modeled. This is, for those of you who don't recognize this particular modeling technique, is event modeling. So in event modeling, the bounded contexts show up as swim lanes, where we have the respective events for those contexts represented. So in this case, we have a bike rental service, where when I return a bike, there's a bike returned event generated. And if there's something wrong with the bike, I might take the opportunity to report a failure. That particular event, bike report received, is not a domain event. It's something that is going to be published because we want the reporting context to do something with that information. In this case, we want to be able to then send a command, translate it into a command that locks the bike to make sure that nobody else can use it because, well, there's an error or something wrong with it. So we cross sometimes streams. That's a Ghostbusters reference, for those of you who've seen that movie. So some events in this event model are explicit milestone or integration events and not the main events. So you can actually model this before you get to defining your API. So how do we generate events inside of a bounded context to then publish through an API? How many of you are familiar with change data capture? Probably some of you. So this can seem like a solved problem, which is true to some extent. So you have some type of internal table in a database, and you can apply this technique of capturing the changes that occur to various records through a connector. The BZM is something maybe some of you are familiar with as well. And then this connector will publish those changes onto a Kafka stream. Pretty simple, right? There are some drawbacks with this mechanism, though. For one thing, the internal domain model that we have in our database is directly exposed to the outside world, which is probably not something you want to do or expect consumers to understand. This is an internal detail that we need to hide to make sure that we promote loose coupling. Not only that, but every update to each row in the table is captured. So those are pretty crude events, created, deleted, updated, etc. But they don't represent actual business facts that we design ourselves. And we get a lot of them, of course, as we update our rows. And also these events are containing normalized data because they basically capture whatever is in the table. We, on the other hand, when we want to publish something to the outside world, want denormalized data. Much like when we create projections, it's a denormalized view. So just using CDC off the bat gives you some drawbacks that you need to entertain and possibly solve. One way of solving this is by introducing outbox table. Also probably something that you've seen before. So now we don't just use an internal table, but also couple it with a special table, which will be the basis for capturing the changes. So we get a chance to, for example, denormalize the things that we're interested in inside of this outbox table and apply CDC to that one. So in this transaction, we both store something that's important to us internally, as well as in a separate table that fulfills our needs in terms of publishing an event stream. Now, this is good, is better, but you still need to change things, especially in your applications. And you have a transaction introduced as well. And still, you're not capturing the actual business facts. So you're conforming to or expecting pretty crude events going forward. Now, let's say that you're in the position of using event sourcing. So you have this setup, and you also want to be able to build new application services using event sourcing. What happens if you introduce that to this picture? You get an event store, a native storage for events of the internal event streams. You consume them in an event handler. And this event handler will then perform that transaction I was talking about. Now, how many of you think that this is a particularly nasty setup for something that should be maybe a lot easier? I see some hands, so that's good. This can become quite messy because in our event handlers, when we create our projections, we might have multiple databases, multiple tables, etc. So the CDC part can be increasing, where we kind of lose control over our main event streams that we're concerned with. So this can become kind of a hassle. Also, to just note one particular fact, all the state that we need is already present in the events that we consume. So whatever happens in the aggregate and the state that is then streamed over to us in event handlers we should be able to recreate the full state that was in the aggregate. There is nothing else in the database specifically that supplants that information. So we're only concerned with whatever we get from the events. So we're complete in that sense. If we take that fact into account and reduce the complexity in this slide, you get something much more elegant. Still have your event store, your stream of events, your event handler, but now we skip the part of separate databases and their own CDC connectors. We apply some form of event transformation or transformations and are in full control of our event stream, our main event stream, or possibly several, depending on the layout of our EventDriven API. So this is simpler, it's better, I think, but there's some subtle details that we need to be aware of if we want to implement this particular setup. Before we do that, I want to answer the question from the previous presentation. So we need to be aware of two different types of events. Domain or delta events, and the next type of event that we'll show on the upcoming slide. So the domain events describe changes, therefore the delta name. And they are the ones that are persisted in our event store. So that's the type of event that we're dealing with inside our context. So that's the whole point. We're using those delta events to build up the state that we desire in our projection in our event handlers. But they do not apply really to the outside world. Why? Again, coupling. If we were to expose our domain events without any modification, we allow the consumers, unfortunately, to couple again on our internal domain model or the events that represent it. And we also need to replicate whatever event handlers are doing inside our context, in other consumers, in some other contexts. Not desirable. Also, producers are not sort of completely free from the consumer concerns, because not all consumers want all events. Some consumers might have requirement to maybe say get only shipping confirmed and shipping canceled, and not care about the other events to build up their state. So we're talking about two different types of sets of events that the consumers tell the publisher or the producer, please care about me in this way. That means that we're putting some more logic on the producer side for the consumer to be happy. And also an important fact, you can't compact these event streams. What does that mean? In typical event brokers, you can compact the stream to only retain the most recent event for a particular key. You might have a compaction lag, so you retain some history, maybe for 24 hours, to do some consumer processing if need be, so you have some window to use. But this means that if you were to just publish domain events out onto the public event stream, you would basically get a duplicate of the internal event stream, which is not what for example, Kafka is supposed to be used for. There are good articles from AxonIQ about this topic, but this is key. You basically get the same event stream replicated. The type of event that I suggest to use for publishing externally is the event carried straight transfer event. And you might summarize that as the full state of an entity, or, as I also like to call it, the full state of a business occurrence or circumstance. It doesn't have to be one entity, but it can be something that contains a snapshot or the full state of something that might involve several entities. So consumers now have this to derive their own state from. So they can materialize, they can aggregate several event streams to arrive at whatever they need to maintain. But this type of event doesn't offer the why or the how. So it's up to the consumer to deduce what change occurred between one type of event or one instance of this event to another. Now, this is easily to be replaced. You can compact this because each event is carrying the same key. So it's very useful, for example, publishing to Kafka, or I guess Solus as well. Just to make this even clearer, this type of event, let's say we call this stock changed. In the previous slide, we had a stock decreased event, which carried the amount of stock that was decreased, the change. Whereas in this instance, we have the current quantity. Does anyone know what this is, why this is good, to have the current quantity instead of the change? Idempotent. If we, for some reason, process this now a consumer, but the ACK to the broker fails, so we get the same event again, we just update the same current quantity again. Or if we have done that and we suddenly need to make a diff, well, it's super easy. So we have a much easier time to implement idempotency. Question though, orchestration. You know, sagas, you have something that straddles two or more contexts. Do we use these types of events for orchestration or domain events? It's a kind of a tricky question. If you take a look at the Axon example, they typically implement sagas using delta events, domain events. Why? Because it does involve both context and some more intimate knowledge to make sure that the workflow functions as expected. Also, it's not the case that any context can just subscribe to these kinds of events. A workflow is carefully designed, so it's not like I can suddenly enter a transaction by virtue of the EventDriven API. It's something that is carefully orchestrated. So it's not always the case that everything that is published from a context is supposed to follow this particular type. So sagas are perhaps a special case. So, event transformations. We have basically three types of transformations to apply. One is simply mapping one-to-one. So we get an internal domain event, and we want to map it to something that we publish externally. We might change a field or two, but basically it's a quite straightforward transformation. We have the more common one, which is combine. Maybe you can call it summarize. It's better, I think, because this implies that we have 3 parallel events. Maybe that's not the case. Think of these 3 as consecutive events. And at some point, we decide that on event number 3, in this case, we publish a summarized event or combined event of those 3. That's typically what you do. You take a number of domain events and publish one event from your API that sort of carries all the information that is necessary from these 3 separate internal domain events. And finally, you have the more rare case of splitting an internal domain event into several external events. But this is the one that is the most frequent transformation you will probably encounter. If you want to implement this, you have to start by looking at what we have inside a particular bounded context. So let's see how we can use Axon Server in this case, inside a context. We have our command handler. We apply a command. We generate an event. This event gets, of course, appended to the event stream for that aggregate. Also, it gets published onto the event bus. We receive it in our event handler, and we create our projection. All this is fine inside the context. Remember, we are supposed to handle internal domain events inside the boundary. So this routing is fine as long as we don't cross that threshold. That's a bit unusual because Axon Server seemingly allows for routing across any kind of boundary. But keep in mind that Axon Server, the messaging in it, functionality in it, is used only within the context in this particular scheme. Now, of course, the event storage that Axon Server provides can be used in multiple contexts, but the routing of events is contained or confined to a single context. So imagine this command handler and event handler being 2 different processes, 2 different microservices. They're still within the same boundary. So if we take a look at the projection that we create, there are various ways to apply these transformations. I love state machines. They are everywhere and they are simple to understand. So this is the solution I propose here. You can probably do it with reactive streams, but maintaining state that needs to be persisted, it quickly melts my brain. So I tend not to focus too much on those solutions, and particularly as it pertains to this scenario. But if you use a state machine, we basically need to do 3 things. We will need to have a state machine for each aggregate. So when we get a domain event in our event handler, we retrieve the state machine for this particular aggregate. We transition our state machine according to the event we receive. And we also update the context or the model that the state machine keeps internally. And finally, if the transition we just made implies that we need to emit an external event. For example, we have received 3 different domain events, we've transitioned accordingly, and on the 3rd transition, that's where we apply the transformation. We get the state we need from within the state machine, or the model information, and we publish an external event, the summary event, containing exactly what we need to expose for consumers. This is something that is not tricky to implement, but it's important to realize a few things. One, that this is at least once delivery. So if we fail to publish, for some reason the event broker doesn't accept and doesn't acknowledge our event, we'll still rely on AxonIQ's event processor to retry it for us. So we might accidentally publish the same event multiple times, just to be aware of it. And these events are not supposed to be replayable. We replay events inside the context, but we don't extend that outside the context. We have replay mechanisms in Kafka, in Solace, that we already can take advantage of. So a replay internally in a context stops at the border, at the boundary. just to be super clear about that. Also, you might have different brokers possibly for different events. So I would suggest that you have adapters when you publish that combine the type of broker, the topic, and their key, partition key, so you can switch them easily depending on what kind of transformation and publication of event that you do. So let's see an example of where we do something within a context that in turn exposes an event onto a broker and triggers a business activity in another context. So we start with the first context. We got a command. This command is handled in a command handler. And we generate an event, of course, published on an event bus. Again, all of this internally in the context. In the event handler, we create our projection, we manage our state machine, and we suddenly realize that we need to publish something. This state transition right now implies a publication of an event. We publish an integration event. Milestone event is also another name for it. And the other context receives that integration event, carrying the full state of an entity, of a business occurrence. And in this case, we translate the event into a command to update something inside the second context. Some interesting hard parts about this, which probably deserve their own talk. How do you evolve the schema? You have two different streams, one internally and one externally. The internal one you can manage quite easily most of the time with forward and backward compatibility. But if you do that and you change those things, it might impact the external schema defined by the API. And that changes much more slowly. Why? Because you need to negotiate those changes with other teams. So be aware of the impact of changing the schema internally and how it impacts external streams and downstream consumers. Also, when is the starting point for publishing an event? So if we have event processor in Axon, it always starts at the tail, the first token. So that's the beginning of time. That might not always be the case. You want to start at a later point in time. So that could be something to think about. Where do I start? How does my event handler that has the state machine handle events that are not completely from the beginning? You might be a bit lenient in how you handle that, or do some manual ad hoc accommodation to make that work. And finally, how do you describe the event-driven API? This is where the specification AsyncAPI comes in. Again, it allows you to define where the broker is, if you can subscribe to it, what the schema is, how you discover it, access policies, and much more. But this is super important because it allows consumers to more intelligently utilize your event-driven API. But again, these are things to be aware of once you've gotten on board about using this particular mechanism for turning internal event streams into external ones. That was it. So if you have any questions, please ask them now or get in touch. I'll be here the rest of the day, so looking forward to further discussion.
All right, so it looks like we have a few questions. Thanks, Mark. So the first one, couldn't you combine, I can't remember what ECST, the acronym specifically stands for out of your presentation, with some more meaningful names to capture everything, like a stock decreased event containing a new stock property?
Sure. I mean, you can, of course, name your event carry state transfer events to have more meaningful names. However, be aware of, or be careful not to use the name of the event as something to indicate change. If you need to provide any hint of a change, do so inside of the event. Because again, we don't want to couple changes on the consumer side to what happens in your internal domain model. So yes, you can name your ECST events more meaningfully, But don't use that as an indicator for performing or deriving state in consumer according to just the changes. We always provide as much state as possible to consumers. Yeah.
Because they can be compacted at the end.
Compacted at
always
the end,
want-
yes.
Yep. All right, so the next one, it feels dangerous to have an event handler publish another event. Wouldn't it be more secure to have an intermediate command before applying that second event?
I would say that there's no state update or new event to append to the internal event stream in this case, and it's not that dangerous from what I can gather to publish an event from an event handler. That's doable. You know what kind of event handler does that? Axon's Kafka extension. It is an event handler. So it just does just that. Whether or not Kafka produces transactional or not, it still publishes an event. This is the same principle. Yeah.
Same concept. All right. Can we use AxonIQ, Axon Server maybe, or Axon Framework as the cross-context message broker? What would be the issues to be wary of while doing so, or what would be the different capabilities that other message brokers would bring that we would benefit from? Does that make sense?
So infinite retention is one thing. We often want our broker to retain things as long as possible, if not infinitely. Kafka is such an example. Pulsar, I don't know if Solus does. But the messaging infrastructure in Axon is not that, because we have an event store for that purpose. However, we use the messaging infrastructure for commands and queries. That's perfectly fine. We don't need a broker for that. But for events specifically, we need an additional piece of infrastructure, the event broker, or even in a full-scale event mesh if that's the need. Okay. But this is event-specific. Not the commands or queries are still fully capable to be routed wherever they need to go by the Axon server.
All right, sounds good. Any other questions from anybody? Nope.
I was wondering if you think that every time you have a system with multiple bounded contexts and you are integrating those bounded contexts, people should use this ECST pattern, or if maybe there are other patterns that people can opt to use, like the sagas.
I mean, this particular event type is the most suitable, most generic one for supporting any type of workload that consumers implement, operational, analytical. So if by default, if you need to choose one, that's the one. You mentioned the Saga case. That's the one where I'm still ambivalent. I think you can make a compromise and utilize the knowledge you have of the internal domain events to make the Saga happen, because it's a separate component that needs to know what's going on in both contexts. So it's a specialized case. I don't know if that was the answer to the question, but...
Yeah, to me it almost feels like a Saga. You are making a tailored one-on-one integration between one bounded context and the other, and you're really deliberately thinking about how are these things related, and you are expressing the outcome of that deliberation in code, whereas this just provides some kind of blanket open host access from any bounded context to one.
Yes, that's the way I approach this. The EventDriven API doesn't have any Saga transactions figuring into design of it. It's just something you can consume that supports a wide array of scenarios on the consumer end. That's, I think, the best approach to take when you start out with event-driven APIs.
Any other questions? Oh.
Yeah, Mark, what do you think about having callbacks to manage the versioning of the events? So rather than publishing the entire set of like the stock change, you probably would do that, but have a callback URL so that the consumer can get this change event?
I try to avoid any callbacks if I can to, because I want to avoid stale data. So to minimize interactions between contexts that are synchronous is a good starting point, I think. But sometimes you need them. You can't escape it. So that's an option, but I try to minimize those types of communication patterns. Yeah.
Thanks. Anybody else? No? Okay, well, if that's the case, thanks for your time, Mark. And
Thank you.
Thanks, everybody, for attending. And lunch will be next.